Hey, and there. Welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name of news, where we just bring you the most detailed space weather and comprehensive solar imagery you'll find in the known universe. We've also got a coronal mass ejection headed Earth's way. We'll talk all about it on today's Daily Space Weather video. We've also got a huge number of filaments and a very high likelihood for large solar flares. Upticks all around in all of the stats. Also, check it out, a huge crown prominence hanging out up here. That's a filament that could use a name. And by the way, we've been naming filaments after living people over on Twitter. So make sure you follow us over on Twitter. We're all over the internet at Smash-O-Mash. Here you can see some major plasma reorientations happening right about there in the northwestern limb. Again, there is a coronal mass ejection headed Earth's direction. You can expect to see that arrive sometime after midday on Thursday, April 19th. So there's a huge propensity, let me go back here a minute. There's a huge propensity for large solar flares from this sunspot right here as it approaches the limb. It is a big sunspot. It is magnetically complex. Also a huge possibility for large sunspots from this huge string of sunspots. There's like 4 or 5 named groups in there. And here's a close-up of that. These are all 24-hour videos, by the way, 304 plus 195 angstroms from the GOES-R. And last but not least, here's the northeastern limb. There may be a sunspot hiding back there behind the limb somewhere. So we'll be keeping you posted on that as well. Let's take a look at this huge filament up here, which was named by one of our viewers. Thanks to Skything for naming that filament. Again, if you want to name filaments, make sure you go follow hashtag #NameThatFilament to name solar filaments after living people over on Twitter. Hashtag #NameThatFilament. Next, yesterday plus today in SDO intensitygram, most of these spots have been largely stable over the past 24 hours. No major changes happening there. And here's your SDO magnetogram, which we normally speed that up a little bit. There's the normal speed we usually show. These images are yesterday plus today. So a little bit of umbral migration happening in this sunspot group. You can see that leading North Pole umbra there rotating a little faster than the trailing South Pole umbra. And it may be drifting a little bit toward the equator also. A thing that occurs. Yeah, sunspots. They drift toward the equator throughout the solar cycle. If you enjoy the content, consider helping us out with clicks. And welcome to the Neo-Renaissance. Smashomash.com is a website that we created back in February of 2019 in response to the pathetic and putrid censorship of Facebook. As we got banned for doing nothing in particular, we got some kind of a temporary ban or something. So we said there's got to be another way, and the other way is to rent your own servers and have your own domains. Because if you can't join them, beat them. Smashomash.com. So support the channel via clicks if you're unwilling to support the channel via dollars. Today's featured product is Shartlight, as there's a lot of crap on the internet. And by the way, save 20% on checkout with the promo code TEACH20 from our Redbubble shop. Links below the video as well as on the homepage at smashomash.com. So Shartlighting is when somebody attempts to gaslight you on the internet especially, and fails because you've got a better memory than them or you're not going to believe whatever nonsense they said, as gaslighting is attempting to get people to believe that history happened in a different way than it actually did. It's basically a psychological abuse. And if somebody fails to gaslight, there should be a new word for that, so we made one up, shartlighting. Just imagine trying to light a fart and crapping on your hand and lighter. That's a perfect metaphorical algorithm, a metaphorical allegory of what it's like when somebody fails to shartlight you. When somebody fails to gaslight you, rather, they've shartlighted. And basically just crapped on their own credibility. So we do invent words. You can find find more custom words over at our forum. You can also find links to our Hemp Lucid shop below the video and on the homepage at smashomash.com. So a huge 420 sale going on where you can save 40%. Enter the promo code SMASHOMASH on checkout if you're shopping on the Hemp Lucid shop. HempLucid.com. Thanks to our latest affiliate/sponsor. There are the most popular items. And you can also click the link on the homepage or below this very video to shop on the Hemp Lucid shop. So help out the channel that way, or consider becoming a member of the Smash team. There's a bronze level, which is $0 per month. There's also a silver level, which is $2.99 a month, and a gold level, which is $9.99 a month. There's also a gold annual paid-up subscription, which is almost like getting 4 months of a gold membership for free, as it includes complimentary merch. These videos are brought to you in part by the Smash team and in part by Smash staff and I, who put out this content at massive personal risk and expense. So please consider supporting the channel, especially if you would like to see these videos remain existent and free for everybody to publicly view. Let's take a look at volcanoes. Shivaluch continues with its explosive activity here. A major eruption continuing there at Shivaluch. It's still producing a 38,000-foot plume of volcanic ash, or flight level 380. Don't fly your ultralight aircraft over Shivaluch. Abiko also erupting, flight level 100, 10,000-foot ash plume over Paramushir Island. Subanosejima exploding, 4,000-foot ash plume over the Ryukyu Islands from Subanosejima. Mount Ibu exploding, 6,000-foot ash plume over Halmahera, Indonesia. Also Dakono on that same island. Little bigger ash plume there, a 19,000-foot plume of volcanic ash there, flight level 190 as Dakono explodes. Popocatépetl exploding in central Mexico, flight level 220 from Popocatépetl. 22,000-foot ash plume. Fuego, 15,000-foot ash plume over Guatemala. Nevado del Ruiz, 21,000-foot ash plume over Colombia. Ecuador, we've got Sangay and Revenador both exploding. 21,000-foot ash plume from Sangay, 14,000-foot ash plume from Revenador, and not sure if Sabancaya in Peru is erupting or not. Please do not pole vault the caldera. Let's take a look at global seismicity. So there is the past 90 days, conveniently shown in bar graph form from Volcano Discovery. And here's the past 24 hours. So no major quakes, although this one was pretty big. A 5.9 in the south central Indian Ocean there, southeast of Madagascar. That was at 15:01 Universal Time yesterday afternoon. There was also a 5.5 only 6 minutes later on the northeastern coast of the Indian Ocean there, that one at Indonesia. We'll report other quakes over a 5 magnitude like this 5.0 in the southwest Indian Ridge. Looks like an aftershock of that earlier 5.9. Also, we've got a 5.2 there in the, is that the Leeward Islands? 39 kilometers east-northeast of Codrington, Antigua, and Barbuda. So a little bit of a swarm happening there in the, just to the east of the Caribbean. That 5.2 came in at 9:49 this morning. We also have a 5.1 there at Guadeloupe. So hopefully those are not foreshocks. Keep in mind, any earthquake could be a foreshock, and let's get back to space. And thanks for leaving comments. One audio. That is Robert and Mr. Bordages. All right, so we're back to space. So here's the past 24 hours in GOES-R, 171 angstroms wavelength. And by the way, the 10.7 centimeter radio flux is now all the way up to 176 solar flux units. So, yeah, 176 is the new number for the radio flux. And for you new viewers, the 10.7 centimeter radio flux is the most proportional data set we have to sunspot number. So, when you have a high sunspot number, you tend to have a high radio flux. As you can see, basically all of these peaks are accompanied by peaks with the black line and the red line. The red line is the sunspot number, the black line is the radio flux. That is a 1-year graph from solon.info. Solon.info, if you want to look that up yourself. 176 is the new radio flux number, having broken out of various different support levels there. Perhaps the solar activity is now off to the races. Space Weather Enthusiast dashboard not forecasting any geomagnetic storms or geomagnetic unrest. I'm sorry, April 19th is actually Wednesday, so we're expecting a coronal mass ejection impact Wednesday, sometime after midday April 19th on Wednesday. We'll tell you why here in a moment. It looks like it's going to be a pretty significant one also, as it is quite perfectly directed toward the Earth. So that's what's going on for the NOAA forecast there. We'll see if they noticed that coronal mass ejection. Let's take a look at some magnetic data. Here's Earth's magnetic moment from space for the past 4 hours. It's our Geospace Magnetosphere movie, which the channel shows daily. Things are quite geomagnetically calm here. And by the way, the CME that we forecasted last night did show up. It just must have been moving a little bit more slowly than we expected. There was a signal, which we'll get to here in a minute. All right, so that's the past 4 hours of Earth's magnetic moment from space. Again, geomagnetically calm conditions. Here's Earth's magnetic moment from the ground. We like to show this daily also because a lot of people on YouTube that pay attention to space weather are very, very scared and spooked to the point where they've moved to a bunker because they're afraid of the pole shift. And of course, if the pole shift was really that serious, it would be reflected in this data, which it doesn't really look very scary at all to me. Let us know in the comments what you think. That's the last 4 hours of Earth's magnetic moment from the ground. And the planetary K index is currently at 1.33. Again, geomagnetically calm conditions. KP 1.33 is the planetary K index. Next, looking at the real-time solar wind measured outside Earth's magnetosphere out here at Lagrangian point 1. And you can see right in here, there is a CME impact mixed in with this signal. You can see some very high density stuff showing up there. We did see densities make it all the way up over 100 protons per cubic centimeter, but only for a brief fleeting period of time. There's a reading of 130 protons per cubic centimeter. So that CME was a correct forecast. It was just moving a little bit more slowly. And of course, the more perfectly earthly directed a CME is, the harder the trajectory is to, the harder the velocity is to measure, especially when we've got stereo A as close to the Earth as we have it. So yeah, there's that CME impact. We expected it a little bit later. I thought it was moving a little bit faster than it was, apparently. Current conditions are, and by the way, that is the ACE and Discover. Current conditions are solar wind density about 2 protons per cubic centimeter, solar wind speed only 344 kilometers per second. Let's take a look at some more magnetic data. There are our GOES magnetometers measuring the magnetic field from their geosynchronous orbits. They're at about 23,500 miles of altitude, and they're geosynchronous near equatorial in their orbits. Pretty smooth there, no big deal going on with the GOES 16 or GOES 18. Earth has recently, just in the past couple of hours, moved into the South Pole current sheet, as we forecasted in yesterday's video. So here is the heliospheric current sheet. Earth has just left the North Pole current sheet, depicted in green. That is the polarity of the solar plasma. And here is the South Pole current sheet, depicted in red. Earth has just snapped into it just a couple of hours ago. So that's our top view ecliptic plane field plot. And let's do a line of sight field plot next. Here's the sun's B field in blue. You can see that sector boundary crossing moving in. And there's the south solar polar field there shining through from behind the B field, depicted in blue. South solar polar field there depicted in red. We'll also show coronal holes. Here's our coronal hole line of sight plot. And we've got some transequatorial South Pole oriented coronal holes here rotating in. Take a look at the SDO's view. There's the latest image. So these coronal holes down here in the southeast are South Pole oriented coronal holes. These coronal holes over here are North Pole oriented coronal holes. Also a great view of this plasma reorientation. The CME that's headed our way is from down here. So right there you can see that little puff happen. That included a coronal mass ejection that is headed toward Earth. We'll get to it in a little bit more in-depth fashion here in a minute. First, sunspots. So I think there might be one new named sunspot group here. I think this group up here is still a sunspot. We'll show you a high-res image toward the end of the video to verify that. Besides that, I don't think any changes here. So we may have one more sunspot today. We don't get into things on the channel like trying to count sunspots because of the counting convention being a little bit complex. It's anyway, let's just move on, realizing that the likelihood of large solar flares is very high, especially from this sunspot group here, this group down here, and this group setting on the western equatorial region. So here's the past 24 hours from the SDO continuum. And all right, there is no sunspot way up here. All right, so that's looks like we'll have a similar sunspot number today than we had similar sunspot number to what we had yesterday, it looks like. And yeah, only minor evolution happening there, especially up there in the northeast. Most of those sunspots largely stable. Let's continue on to energetic particles and solar flares. No spikes in the proton flux, and really, solar flaring's been underperforming. So we're showing the 7-day graph here because we have shown this rather precipitous uptick in the background X-ray flux. You can see down here the background X-ray flux was about B6.55, and now the background flux is all the way up to about C1.67. So that's a significant uptick there, despite no major flares. In fact, only C-class intensifications of the past 24 hours. Could be the calm before the flare storm here. There is certainly sufficient amount of material suspended between the Earth and Sun and magnetic field complexity to produce X-class flares. Don't be surprised to see some. Here's the past 24 hours, and goes our 94 angstroms. Again, the places to watch for large flares, folks. This is the most likely spot to see an X-class flare. The second most likely place to see one is probably here. And the third one would be anywhere around this area. So those are the current places to keep an eye on. And when I say eye on, well, pardon the pun. Here is 131 angstroms also, to give you a different wavelength over the same period of time. And now that we've gone over that, let's take a brief moment to orient ourselves to the solar system. If you want to create your own star chart, head to skyandtelescope.org. That's the one we're currently using. Of course, there are many different choices for online star charts. And I'll just press the Now button. If you're up in the early morning hours, you may see Saturn and the Moon very close together there. The crescent moon there, just southeast of Saturn. Also, the Sun chasing Jupiter, and Mercury chasing the Sun, and Venus chasing Mercury. So if you're up after dusk, you may see Venus up there in the early evening sky, the third brightest object visible, at least in terms of its actual brightness, not in terms of its intrinsic brightness. How about a solar system forecast? Yeah, is where things are now. We'll advance it 1 week. And yeah, is where things will be on April 23rd. Continuing on to our coronagraphs. And you may see something looking like a halo there. That is an Earth-directed coronal mass ejection. It didn't really show up too well on the computer-aided imagery there, but quite sure that is earthly directed. So that's only that's earlier this morning. It happened just before midnight. So you're not going to see too much on this image. These images, these are yesterday. That's 104 frames from yesterday. We're going to go back to today here, as that is where the CME is going to be visible. Coronal mass ejection headed your way. So here are today's images. And you see right there at the beginning a halo-like appearance. That is a very precisely earthly directed coronal mass ejection. So we'll show you stereo A's view also. Here's stereo A depicted on the left. And the reason that we show this imagery is because stereo A is overtaking Earth. And soon it's going to be on the opposite side of the planet, providing even less ability to calculate velocities and trajectories of coronal mass ejections. So that's unfortunate. I mean, eventually it's going to continue on and it'll provide a little better view, but at the moment it's providing a pretty bad view. Too bad we can't speed up stereo A. Anyway, late in the day yesterday, that coronal mass ejection occurred. It looks like a bunch of missing data there, not making things very helpful. Let's see what we see on the Soho Lasco C3. So I believe this CME that's coming out of the southwestern limb, you can see right here, there's some material coming out there. I believe that does have a significant earthly directed component. And it was certainly from material released on the Earth side. So again, we can expect that to arrive mid to late day on the 19th. So here's a 24-hour video. The time and date stamps are down there in the lower left. Let's zoom in a little bit closer. And you'll actually be able to see the material from that puff that I showed you earlier. Let's get a little bit closer here. You're going to see right from this area down here, right there. Earth-directed coronal mass ejection expected to arrive sometime after midday on Wednesday, April 19th. So that could produce some aurorae. We're hoping for some clear skies and aurorae at mid-latitudes. Here's just 195 angstroms, which is what was in the middle of that coronagraph imagery we showed. And that CME came from this area down here. We'll let that play through one more time to show you the release. Didn't really show up very solidly in that wavelength. So a prime example of how different wavelengths can show you vastly different features. And let's move on to look at filaments. So there are still an incredible number of filaments on the Earth-facing portion of the solar disk. Some of these could be named after living people if they aren't already named. Again, follow the hashtag #NameThatFilament over on Twitter. Let's just bring up the latest image here. So some certainly huge filaments indeed. If I were going to name one, I would probably name this Crown Prominence. But hey, again, thanks to our new Twitter followers. If you don't have an account over on Twitter, perhaps create one, as you'll see information over there that you will not see anyplace else, as we sort of compartmentalize our content a little bit. So go follow us over there. And if you think free speech has been restored by Elon Musk, please emerge from your fantasy world and enter into reality. This is the past 24 hours of GOES R 304 angstroms. Looks like a bunch of campfires there burning in those active regions that I mentioned earlier in the video. Just to reiterate, the possibility for X-class flares lies here, and to a lesser degree, over here and over here. Those are the areas to watch. Let's see what's going on in the past couple of hours here. From the available at the Space Weather Prediction Center, the GOES 16 SUVI. So good that we stream it regularly on the Twitch channel. And you can see some rather unstable looking plasma hanging out down here in the southeastern limb. And this brings us to our bonus features segment. So bonus features are starting out with charging hazards. We ain't got none. It's smooth sailing for satellites. If you want to follow the possibility of satellite charging hazards yourself, head to the Space Weather Prediction Center's Satellites Community Dashboard. You can check it out yourself. And the GOES electron flux here still at quite low levels. We may see a minor uptick in this before this craters again as a result of a coronal mass ejection impact. So that's the past 3 days as measured by the GOES 16 and GOES 18 using radiography from their geosynchronous orbits. They measure it at the F layer of the ionosphere. And you can see NOAA kind of forecasting low levels of electron flux to continue. There's the 1-year graph to put all of that in context. That's also from solon.info. Solon.info/solar. And next we'll show the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with the data depicted. So we'll show vibrational frequency as well as the anomalygram. So here's the raw vibrational frequency of the ionosphere, the bridge between Earth and space. It's located at about 300 kilometers of altitude. The F layer. And I don't think anything too exotic is going on, but just to make sure, we'll show the anomalygram. So there is the anomalygram. That's anomaly in megahertz from the 30-day median. We show it daily on the channel. In other words, our channel has like a 5+ year record of what's been going on in the ionosphere. Perhaps there's a way to tie certain things together to other things that we're not aware of. As in science, one of the things that we notice is that immersion in the data often leads to answers to questions not asked. So in science, we ask questions. Oftentimes we don't. And for the most part, we don't receive answers to the questions that we ask because everybody's asking those same questions. But oftentimes, the additional questions created and the answers to questions not asked cause us to make breakthroughs. Anyway, there's the latest image. That's 12:30 Universal Time, ionogram, and anomalygram. Total electron content depicts the free electrons all the way from your GPS handset up to your GPS satellite. That GPS satellite must communicate with your handset through the inner portion of the outer Van Allen belt, the outer plasmasphere, which is right here, the inner Van Allen belt right here, the inner plasmasphere, and the ionosphere. And those free electrons cause signal refraction, which is what the total electron content forecast is showing. And the way it works is ground-based stations know where they're located, and the satellites know where they're located, and when they talk back and forth, they can measure the signal refraction, which gives an estimate of the free electrons between the ground station and the GPS satellite. So those are the most likely places for GPS errors. We normally show the North American total electron content forecast the anomaly at least, but it's not really working right now. So we'll move on to show the latest intensitygram and latest colorized magnetogram. So that's quite a bit of activity there. Again, radio flux up to 176 solar flux units. Do we have any new regions rising? Let's take a look at the eastern limb real quick. No new regions rising yet. There's the full disk view. And just one more time, the most likely places to see large flares are especially here, but also in second place here and a close third down here. Very likely to see M or even X-class flares in the next 24 hours. Next, let's take a look at Croissant Earth, projected onto a fake NASA Adobe Photoshop globe to convince people for some reason that the planet is shaped like an oblate spheroid, when all of our viewers are aware that Earth is croissant-shaped. Yeah, it's shaped like the the French breakfast pastry. So stop believing NASA's lies and check out our Redbubble shop. The merch is just awesome. We're looking at sea surface temperature here. Let's take a little bit of a global look at what's going on with sea surface temperature anomalies, which is what's being depicted. So there is the Arctic. Here is the Antarctic. And the animation that you see there is currents, and the shading is sea surface temperature anomaly. So you can see there it's kind of cold on the Pacific side of the Drake Passage and a little warmer on the Atlantic side of the Drake Passage. Let's take a look at Earth's largest surface heat sink. There is the Pacific Ocean. And by the way, this lack of extra cold equatorial Pacific water is an indication that you're not entering into an ice age, that La Nina is in the process of ending, and the likelihood of El Nino is increasing. So I guess that's just another nail in the coffin of the grand solar minimum nonsense that some people, for some reason, keep chanting. They keep chanting it as if it's going to come true if they keep saying grand solar minimum, grand solar minimum, grand solar minimum, grand solar minimum. Apparently it's convinced a lot of cultists that it is true. They're hanging on to absolutely nothing to hold up their dogmatic cult nonsense about a grand solar minimum. So that's the sea surface temperature and current situation of the Pacific. Let's don't forget the Indian Ocean. There you go. There are the currents and sea surface temperature anomalies over there. And here is the Atlantic. And by the way, a bunch of cold water there in the Gulf Stream area, but also some very hot water. So you can see a huge mix there happening. And the Great Lakes are actually anomalously warm. And check it out, the Gulf. Massive amount of convective energy there in the Gulf. We'll get to it. First, we'll skip to our regularly scheduled surface wind and jet stream imagery. So there are the surface winds of the East, Oceania, and the Far East. Here are the jet streams of Eastern Earth. Let's go backwards for once. Here are the jet streams of Europe, Africa, and the Middle East. And here are the surface winds. Still very windy in the North Atlantic. And here are the surface winds of the West. Very windy in the Gulf. Gulf of Mexico, that is. And there are the jet streams. So some huge bends in the jet streams there. Over North America, at least. Also over the North Atlantic. Some very cold air being shoved down. Way down toward the Azores. All right, so here is clouds and fog. Looking at clouds and fog over the Western world. Using 3.9 nanometer infrared radiation. We had some very severe storms over large parts of the U.S. Wait till you see the lightning map. It's pretty berserk. First, our weather.gov map. If your location is lit, just head to weather.gov and click your location. There are a little bit too many weather alerts for us to cover in this video. Weather.gov. And we've got some winter storm warnings there, it looks like, especially in Wisconsin. So here's your pressure and precipitation forecast based on the 72-hour GFS model. It looks like the severe weather is now subsiding in the Gulf. And there is ice. Yeah, ice coming to Minnesota and Wisconsin, also parts of Canada, and snow coming to the Pacific Northwest. Let's do a snow forecast. There's the same model, the GFS 72-hour model, and that is accumulated positive snow depth change in inches. Some parts of Wisconsin, they're expecting pushing 2 feet of snow, or well over a foot at least. Also, Minnesota to get mostly blanketed. Anyway, you see the map, hopefully. Continuing on to our GFS 72-hour total accumulated precipitation forecast. So that's what's going on, and let's talk about the available potential energy. 4,586 joules per kilogram available there for convection in the Gulf of Mexico. So all that warm water is leading to upwelling, and cold air coming from the north is leading to massive pressure gradients. In fact, let's show the pressure, although the gradients really aren't that big there. So there's the pressure. You can see there is some wind collision happening there in the Gulf. So even though the pressure isn't that low down here, the pressure is quite high up here in comparison, and that is enough. Here's your zoomed out pressure map. That is the mean sea level pressure, if you're wondering. The barometric pressure at sea level. And look at this insane series of thunder and lightning that happened. Spreading from the Texas-Louisiana border down into the Gulf and all the way across Louisiana. It was a great night for voodoo practitioners, perhaps. I'm not sure if lightning is a spell reagent or not. Let us know in the comments what you think. And let's take a look at a real-time lightning map, as we had some significant lightning strike happening in the Gulf, and indeed that continues. Next time you hear thunder, check out lightningmaps.org. Save that one in your favorites. It could save your bacon. So quite a bit of lightning continuing there in the stormy, windy Gulf. It could be some great surf. And let us know if you've surfed the Gulf. We want to see videos. Share it with us on Twitter or perhaps on Instagram. Links below the video and on the homepage at smashomash.com. Now we're going to close things out with U.S. Doppler radar, cloud cover, and water vapor. There is the full 50-state view of ALSA, former nation, now Banana Republic. That started about 2015 with the death of the free press, by the way. Yeah, the death of the free press. Not coincidentally, the same year that a very popular word starting with the letter V was redefined. Yeah. A very popular word starting with the letter V was redefined in the year 2015. It doesn't mean what it meant in 2014, at least not according to the writers of dictionaries. All right, so here is our clouds and fog view. You can see that more massive air there moving down toward the Gulf and colliding with that less massive but very warm convective air. So there's a great view of that. All that dry, massive air over Texas, making its way down into the Gulf and creating those massive pressure gradients. That warm, moist air is unable to support that dry, massive air, and that's causing, well, all of that precipitation and thunder and lightning. Anyway, here is your U.S. Doppler radar map to close things out with a recap. Heavy precipitation there, just moving across the U.S.-Canadian border around the western banks of Lake Superior. There is clouds and fog. And there is your water vapor map. Hopefully that'll clear things up if you're having a little bit of doubts as to what's going on with the Doppler. Getting a pretty decent impulse in this area right here to keep that moving into Canada. Anyway, that's about where we'll have to close things out here at the Smash News Network, Least Busted Name in News. Thanks for tuning in. Congratulations on realizing the channel exists. Don't forget to press like, subscribe, share, comment, etc. We'll see you soon. Don't forget to visit the links over here in these type of areas, and I'll see you soon. I've been your host, Dan, a.k.a. Smasher Mash, signing off, and may that solar wind be at your back.